Bright Tuty. Every student matters.
Now let us start the questions here. A solid is in the shape of a cone standing on a hemisphere. So there is a hemisphere and there is a cone standing on this hemisphere. The radii being 1 centimeter. So this is 1 centimeter and this is radius of both the cylinder and the cone. Okay. Height of the cone is equal to its radius. So the height of this cone is also 1 centimeter, right. Find the volume of solid in terms of pi. So I have got the dimensions of hemisphere. So only dimension in hemisphere I need is its radius, which is 1 centimeter. I have got the dimensions of this conical part, which is I have got the radius, I have got the height, which are enough to calculate its volume. So I need to calculate the volume of this solid. So volume of solid is equal to volume of hemispherical part plus volume of conical part. Right. Now you just need to know the formula and put the values. So volume of hemispherical part is 2 by 3 pi r cubed, which is 1 cubed, and volume of conical part is 1 by 3 pi r square h. R is 1, so square it, into h is again 1. So this is effectively 2 by 3 pi plus 1 by 3 pi. 2 by 3 plus 1 by 3 is 1, right. So this is exactly equal to pi and unit is centimeter cubed. So the volume of this solid is pi centimeter cubed. We had to calculate it in terms of pi, so it is equal to pi centimeter cubed. Now Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 centimeter and its length is 12 centimeter. If the cone has a height of 2 centimeter, find the volume of air contained in the model that Rachel made. So what does the model look like? It is a cylinder and then there are two cones attached at both ends, right. The length of this model is 12 centimeter, right. This is 12 centimeter. Diameter of the model is 3 centimeter. So the radius here is 1.5 centimeter, this much. Okay. If each cone has a height of 2 centimeter, so this cone has a height of 2 centimeter and this cone also has a height of 2 centimeter. So what is the length of this cylindrical portion? It is 12 minus this 2 and this 2. 12 minus 4, 8 centimeter is the length or height of the cylindrical portion. Length of cylindrical portion, or you can say height of the cylinder. So this is 8 centimeter. Now I have got all the dimensions. I need to find volume of air contained inside the model. So it will be equal to, so volume of air contained is equal to volume of cylinder. Which cylinder? With dimensions 8 centimeter and radius, height as 8 centimeter and radius is 1.5 centimeter, plus volume of two cones attached, right, with height 2 centimeter and radius 1.5 centimeter. Okay. So it is equal to, volume of cylinder is pi radius squared. So radius is 1.5 or 3 by 2 squared into h, that is height of the cylinder, which is 8 centimeter, plus volume of 2 cones. So I will multiply 2 and calculate volume of 1 cone, which is 1 by 3 pi r square. So 3 by 2 squared into height h, which is 2. Okay. So this is the volume of air contained inside this model, and let us take pi as common. We can take this 9 by 4 also as common, then see the calculation. So this 3 by 2 squared is 9 by 4. So 9 by 4 pi can be taken as common. 8 plus this 9 by 4 I have already taken as common. 2 into 2, 4 by 3. Okay. So this is 9 by 4 pi. This is 24 plus 4, 28 by 3. So this gets cancelled. So this is 21 pi and it is centimeter cubed. Okay. Now to make this calculation look simple, you can write it 22 by 7, cancel it, and this is 66 centimeter cubed. Okay, this is the volume of air contained inside this model. So what I have done is I have just added two volumes, volume of this cylinder and volume of these two cones. Okay, so what is volume of cone? 1 by 3 pi r square h, where r is the radius of cone and h is the height of cone, and I have added into volume of cylinder, which is pi r square h, where r is the radius of cylinder and h is the height of cylinder. Okay. Okay. So this is another interesting question. A gulab jamun contains sugar syrup up to about 30% of its volume. So there is this sweet. Okay. It has got sugar syrup. It has got many ingredients, out of which 30% is the sugar syrup. Sugar syrup. Right. Find how much, approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with length 5 centimeter and diameter 2.8 centimeter. So this is the shape, right, and the length is given as 5 centimeter and diameter is given as 2.8 centimeter. So what will be the radius? It is 1.4 centimeter. So this is also 1.4, right? We are talking about this hemispherical portion. Okay. If this radius is 1.4, this is also the radius, this is also 1.4. So what is the length of cylindrical portion? It is 5 minus 1.4 minus 1.4, okay, which is 5 minus 2.8, that is 2.2 centimeter. Right. Now I have got the dimensions. So I can calculate the volume of one gulab jamun. Volume of one gulab jamun is equal to volume of cylindrical portion, which is pi radius squared, which is 1.4 squared, into its height, which is 2.2, plus volume of two hemispherical portions, twice of 2 by 3 pi r cubed, right? What is r? 1.4 cubed. So this is volume of one gulab jamun. Okay, we have got 45 of them. So let's first of all calculate volume of one gulab jamun, then we will think about other things, right? So 1.4 square into pi. 1.4 square is 14 square is 196. So 1.46 is 4 square is 1.96, and this pi can also be taken as common. So from inside we get 2.2 plus, I have taken 1.4 square common, so 1.4 is left here. So 2 into 2 into 1.4 divided by 3. If you are not comfortable with taking common, you can calculate it any way you like. So this is 1.96 pi. This can be written as 6.6 plus, this is 2 into 2 is 4, 14 into 4 is 56, so this can be written as 5.6 by 3, right. So 1.96 pi into 12.2 divided by 3 is the volume of 1 gulab jamun. So now I need the volume of sugar syrup. How much sugar syrup will be found there? So volume of sugar syrup in 45 gulab jamuns, okay, it is 30%, right. So 30 by 100, and we need to talk about 45 gulab jamuns, so into 45 into volume of 1 gulab jamun, which is this 1.96 into pi into 12.2 divided by 3. So this will give you 10 here, this will give you 10, right. Now only the calculation part is left. Divided by 10. Okay, I leave this calculation part to you. I hope you can do this calculation yourself, and this will be the volume of the sugar syrup. So what I have done here is I have calculated volume of 1 gulab jamun, multiplied it by 45. Now I have got the volume of 45 gulab jamuns, and then I multiply it by 30 by 100, because sugar syrup is only the 30% portion of it, 30% part of the gulab jamun. So I multiplied it by 30 by 100 for 45 gulab jamuns. This is volume of 1 gulab jamun, right. So this is how we will go about this question, and I leave this calculation part to you. You just need to multiply these three and then take value of pi as 3.14 or 22 by 7, and then find the answer, right. A pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens, right. As you can see in the diagram, the pens are inside this cuboidal shape and the depressions are conical in shape. So dimensions of cuboid are given, radius of each of the depressions is given, so and depth is given. So the dimensions of the conical portion is also given. Find the volume of wood in the entire stand. So as we can see clearly that volume of the wood used will be volume of cuboid minus volume of these conical depressions, right, because the wood is taken out from the cuboidal shape. So volume of wood is equal to volume of cuboid minus volume of conical depressions. So what is volume of cuboid? Dimensions are already given, which is 15 into 10 into 3.5 minus volume of conical depressions. What is volume of one conical depression? It is 1 by 3 pi r square h, where r is radius and h is height, and we have got how many depressions? 4 conical depressions. So 4 into 1 by 3 pi radius squared. What is the radius of one depression? 0.5. So 0.5 can also be written as 1 by 2 squared into depth of the conical depression, which is 1.4. Okay. So once you do this calculation, it will give you your final answer. This is the volume of wood used to make this pen stand. So which is equal to 15 into 10 into 3.5 is 35 minus, this is 1 by 2 squared is 1 by 4. So this can be cancelled with this 4, and 1 by 3 pi into 1.4. Okay. So this is $525 minus 1 by 3, 22 by 7 into 1.4. So this will give you 0.2. So this is 525 minus, this is 4.4 divided by 3. So it is equal to 525 minus, this can be converted 1.46. Okay. So this will give you 523.4 approximately, right? Or you can calculate it exactly. Let's calculate it. 525 minus 1.46, this will give you 4, 5, 3, 2, 5. So this is equal to 523.54 centimeter cubed. This much wood will be used to make this pen stand. So essentially what we did in this question is where we calculated the volume of cuboidal part, and depressions were, conical depressions were there because the wood was taken out, right? So we had to subtract the volumes of these 4 conical depressions. So we subtracted this from the volume of this cuboid and we got the volume of wood used to make this pen stand. Okay. Now a vessel is in the form of an inverted cone. Its height is 8 centimeter and radius of its top, which is open, is 5 centimeter. So we are talking about a vessel like this, where the radius of the top is 5 centimeter. This top is open, right? Okay, we can put anything inside it, and this height is 8 centimeter. Okay, it is filled with water up to the brim. So this is filled with water up to the brim. That means it is full of water. If you put any more water in it, it will come out. So it is filled up to brim. Okay. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. So when you drop the spherical lead shots into this conical vessel, the water will flow out because it is already full. You cannot put anything else inside it without the water coming out. Now, how much water will come out? The water that will come out is of the volume equal to the volume of the lead shots that you put inside it, right? So we need to find number of lead shots. So let us say we have got X lead shots. Volume of one lead shot is equal to, lead shot is spherical in shape, so it is equal to 4/3 pi radius cubed. Radius is 0.5, so 1/2 cubed. Okay, so which is 4/3 pi. This is 1/8, so this is pi/6 centimeter cube. This is volume of one lead shot. So volume of X lead shots is equal to X into pi/6 centimeter cubed. Okay. Now 1/4 of the water flows out. So volume of the water flown out is equal to 1/4 of the water. So 1/4 of the water which is in conical shape. So volume of this conical container 1/4 of that flows out. Okay, so 1/4 of 1 by 3 pi radius squared, radius is 5 centimeter into height is 8 centimeter. So this much water is flown out and it is equal to the volume of x lead shorts. Okay, so we will put these equal. So x into pi by 6 is equal to 1 by 4 into 1 by 3 into pi into 5 square is 25 into 8. Okay, this pi can be cancelled out. So x is equal to 6 into 25 into 8 divided by 4 into 3. So 4 2s are 8, 3 2s are 6, 25 into 2 is 100. So 100 lead shorts, if you put inside this conical container, 1/4 of the water will flow out. Okay. A solid iron pole consists of a cylinder of height 220 centimeter and base diameter 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Find the mass of the pole given that 1 centimeter cubed, this is 1 centimeter cubed of iron has approximately 8 gram mass. So 1 centimeter cube of iron has got 8 gram mass. If I can calculate the volume of iron, total volume of the iron, and multiply it by 8, I will get the mass in grams, right? So I need to calculate the volume of iron in centimeter cubes. So what is the shape of this iron pole? There is a cylinder. The dimensions are 24 is the diameter, so 12 is the radius in centimeter. What is the height? It is 220 centimeter. It is surmounted by another cylinder which has got height 60 centimeter and radius 8 centimeter. So we are given radius this time. So this radius is 8 centimeter. So this cylinder will be something like this. It has got radius 8 centimeter and its height is 60 centimeter. So this is the rough diagram of the solid iron pole. Now what will be the volume of the iron pole? It is equal to volume of this cylinder plus volume of this cylinder. So what is the volume of this cylinder? Pi radius squared, this is 12 square, into height, which is 220, plus volume of this cylinder is pi radius squared into height, which is 60. Okay. So we need to add these to calculate the total volume. So what we can do is we can keep pi outside, and this is 144 into 220 plus this is 64 into 60. Okay. Now you can do the calculation directly, or you can try to take some more things common outside, right? But let me do it directly. 144 into 220. So let's eliminate this 0 and then we will add it later. 144 into 2 is 288, then again 288. So this will give you 8, 6 here, 31680, right? Plus 64 into 60. So it will give you 0, 3840, and there is pi which is multiplied. So pi into, we need to add these, so 0, 2, 4 plus 1, 5, and then there is 3. So this is the total volume of this iron ore in centimeter cube. Okay. Right. So now what you can do is you can also multiply it by 22/7, or what we can simply do it, we will leave the answer in form of pi, and I will leave the answer in form of pi. You will do as per the instructions given in the question. If pi is given as equal to 3.14, you put it equal to 3.14, or you put it equal to 22/7 and do the further calculation. So 1 centimeter cube of iron is equal to 8 gram of mass, right? 1 centimeter cubed of iron has got 8 gram mass. So unitary method, right? 1 centimeter cube of iron has 8 gram mass. So how much mass will have pi into 35520 centimeter cubed of iron will have 8 into pi into 35520 gram of mass, right? Now again I am leaving the calculation to you. In this surface area and volume you will have a lot of calculations. In this, these questions are calculation intensive questions, right? So you should be comfortable doing these calculations without any calculator. So you should practice as much as you can. You do not leave the question at this point, right? So this is how we can do this question, right? So let's look at this next one. A solid consisting of a right circular cone of height 120 centimeter, radius 60 centimeter, standing on a hemisphere of radius 60 centimeter. Okay, so there is this hemispherical bottom, and then there is a right circular cone standing on it, and you notice the radius of both hemisphere and cone is same. So this is 60 centimeter, so this is also 60, and the height is given, height of the cone is given as 120. So this is 120, right? Now this is placed upright in a right circular cylinder full of water such that it touches its bottom. So there is this cylinder, and the radius of the cylinder is also 60. So this will be like this. And notice what is the height of the cylinder? It is 180. So this cylinder will be like that. Right? This is the shape. Find the volume of water left in the cylinder if the radius of the cylinder is this and this. So now what we need to do is we just need to subtract the volume of this solid from the volume of cylinder. So volume of water left in the cylinder is equal to volume of cylinder minus volume of solid inside it. This is the solid that I am talking about, right? A solid consisting of a right circular cone and this hemispherical shape. So what is the volume of this cylinder? We know its radius, it is 60. We know its height, it is 180. So volume of cylinder is pi r square into height 180 minus volume of solid inside it. This solid has got two parts, hemispherical part and conical part. So we need to subtract both the parts. So let's put a bracket here. Volume of this hemispherical part is 2 by 3 pi r cube, which is 60 cubed, plus volume of this conical part is 1 by 3 pi r square. So 60 square into h, which is height of this conical part, which is 120, right? So this is your answer, right? You just need to simplify this calculation. Now this is, you notice pi into 60 cube is there. Pi into 60 cube can be taken out from here also, and pi into 60 cube can be taken out from here also. So first thing I'll do is I'll take pi into 60 cubed as common. So I have taken out 60 from it, so it is 3 now, minus I have taken pi into 60 cube from here, so it is 2 by 3, and this plus sign will become minus. I have taken pi into 60 cubed, so I will be left with 2 here and 2 by 3. Okay. So this is how I do my calculations. You can do your calculations as per your comfort level. Otherwise, you can take common also. This makes the calculation a little simpler. So pi into 60 cubed. This is 2 by 3, 2 by 3, so it is 4 by 3. So 3 minus 4 by 3 is 5 by 3, right? So pi into 60 cube into 5 by 3. So this is the volume of water left inside this cylinder after you put this solid inside it in centimeter cubes. Now you can simplify it further by putting value of pi. If you want me to do it, let us take 22 by 7 as pi, and 60 into 60 into 60 here, 5 by 3. So this will give you 20 here. 20 into 5 is 100. This is 36, 2 zeros, and then 2 zeros for this 100 into 22 by 7, right? Then I will multiply this 22 by 36. This will give me 72, 72, 297, right? 792, 4 zeros by 7. Okay. Now you can convert it into decimal form if you want. Otherwise, you can leave it like that also, right? So this is the volume that we need to calculate here. Okay. Now in this question we are talking about a spherical glass vessel that has a cylindrical neck. Okay. There is this spherical glass vessel and it has got a cylindrical neck. Eight centimeter long. This is 8 centimeter long and 2 centimeter in diameter. So always convert this into radius, which is half of the diameter, 1 centimeter. The diameter of the spherical part is 8.5 centimeter. So this spherical part has got the diameter 8.5. So what will be the radius? The radius is 8.5 by 2. By measuring the amount of water it holds, a child finds its volume to be 345 centimeter cubed. Check whether she is correct, taking the above as inside measurements and pi as 3.14. So you just need to calculate its volume. This time you just need to do exact calculation taking pi as 3.14 so that you can match your answer with the volume of the vessel calculated by this child, right? So what will be the volume? It will be sum of this spherical part and this cylindrical portion also. So volume of the vessel is equal to volume of spherical part plus volume of cylindrical part. So what is volume of spherical part? 4 by 3 pi radius cubed. So what is the radius? 8.5 by 2 and you need to cube it. What is volume of cylindrical part? Pi radius squared. So radius is 1, height which is 8. This is the volume of vessel and we need to put value of pi as 3.14 for the calculation. So let's do the calculation in this question. So 4 pi can be taken out as common. 1 by 3 is left here. 8.5 into 8.5 into 8.5 divided by 2 into 2 into 2 plus 8 pi, 4 pi I have already taken as common. So 2 is left here. Okay. So the only portion 8.5 into 8.5 into 8.5 is tricky, is calculation intensive. So this is 72.25 and you again have to multiply it by 8.5. Okay, 5, 2, 1, right, and you take care of the decimals. 1 decimal point was there, 2 decimal places this, so it will be 3 decimal places. So this is 4 pi 614.125 divided by, this is 3, this is 8, 3 into 8 plus 2. Okay, so what we can do is 4 into pi has to be taken as 3.14. This is 24, right? So 614.125 plus 24 into 2 is 48, and you can write 24 here. Now you can cancel it by using this. Okay, so this is 3.14 divided by 6, and you need to add this. (662.125), right? What was the volume calculated by this child? It was 345 centimeter cubed. And look at this one. Look at this one. If I now divide it by 6, this portion, I'll have 110.354, right? Now look at this child's calculation. It is 345. Look at our calculation. It is 110 point something into 3.14. It will not be equal to 345, right? So from here itself you can say that the calculation of that child is not correct, right? Because this will not result into 345. Or if you have to show complete calculation, what you can do is you can do complete calculation and show the answer. In that case it will be a little lengthier, so I'll leave this calculation part to you. What I am trying to say is, when you multiply this 3.14 with 110.354, it will not result into 345. So from here itself I can say the answer of this child is not correct, right? But if you want the exact calculation here, you can multiply this 3.14 with this 110.354 and you get the exact answer, right? So this was about this exercise here. In the next exercise, we will do some miscellaneous questions based on your previous year board examinations. Thank you.